And we're back. Hi, Jennifer. Good to see you again.
Hello. Good to see you too.
It's like, for people who are watching us on the day, you'll appreciate that this is maybe 15 minutes after the last stream. But for people in the far-flung future, where we're all just floating heads in an energy void, this could have been years between the recordings. You'll never know.
Exactly.
Okay, so we're back. We've got a quick 26 minutes or less. That doesn't seem 22 minutes.
Yeah,
22 minutes,
something like that.
Yeah. So that's plenty of time. Because what we want to do is just teach people the absolute basics of how to become AI geniuses with Neo4j and Spring. And 22 minutes. Who needs that? So I'm hoping you can show us around a little bit, starting with the first principles, like how do I get the database going and all that kind of stuff.
Sure. Yep. So let me just, I guess, share my screen.
Yes. Make sure you've got all your email hidden and all that stuff.
Right. Exactly.
Hi, Melvin.
All righty. We are up and rolling.
Yep.
Okay. So the first thing that I did, because Josh sprung this on me last minute. So
Sorry.
Here I am. That's okay. Spinning stuff up, and we're just going to try to work through things as much as we can in the next several minutes and just see where we end up. But I'll start kind of introductory, and then hopefully we'll get a chance to apply some more in-depth things later on. So to start us off, I went to Neo4j Aura, which is our cloud database as a service. Right now, let's see. Let's just go to instances here so we can see this.
Set a reminder to go book my own Aura instance.
Yeah. So what I did is I just spun up a free tier instance. Yeah, it even says AuraDB free. And you can create a free tier instance, no credit card, no strings attached. You just spin it up. You are capped at a certain number of nodes and relationships. So you can only have a, relatively medium-ish size data store or database running here.
Yeah.
But I just spun this up, and what you get is access to some tools. You can do things like graph analytics, plug in some other things as well, import data if you've got, for instance, like CSV data and so on. But what I ended up doing is out on our GitHub, we have a bunch of database example data sets that you can pull in. So all I did is go out to our Neo4j graph examples, found our movies data set, and just copy pasted all of the cipher and just dumped that into an instance. So that's up and running.
This is like pandas kind of, you just got these like checklists of operations.
Yeah, cool. Basically, yeah. So it ran each of these queries. So created a couple of constraints, index and constraints saying, hey, require that a movie title is unique, require a person name is unique, and then just started creating movies and actors, persons with some properties. The person acted in a particular movie with a particular role. And I think that's, you've got some directed and produced as well. So certain people will direct or produce certain movies. And it loads a relatively small-ish data set, 171 nodes, 253 relationships.
Wow.
So pretty small. These are all the properties you have. These are all the relationship types you have in the database. And these are the node types, node labels.
And there's more relationships than there are nodes because, of course, each node can have more than one relationship.
Right.
And relationships are meaningful.
Yes. Yeah. So that's fairly common that you have more relationships than you do nodes. And that's what you want. You want a graphy data set to put in a graph database. So I just got that loaded. So then we can look at something like the data model.
So cool.
This
has gotten a lot more slick since I looked at it.
It's
really fast.
There have been a lot of improvements. Get that out of the way. So we have person nodes, and persons can follow other persons. So that's this relationship out here. This follows. And then persons have a lot of different types of relationships between movies. So a person can direct a movie, they can write a movie, they can produce a movie, they can act in a movie, and they can review a movie. So all different types of things there. And I guess that's it for this data set. So I just have the database up and running. The next thing, I guess, is to actually do something with this and to plug it into Spring. So I always start with Spring Initializer, fun place, and just kind of charged in generic things. I stick with most of the defaults, but I'm going to add some dependencies. So Spring Data Neo4j is almost always my first stop.
Sure.
Great integration, as Josh has said on the podcast, that it's a long integration between Neo4j and Spring, and still very well maintained. Then Neo4j can also be used as a vector database. So for embeddings, you can retrieve those with semantic search. So I'm going to use Neo4j as a vector store, and then which I'll need to dump some embeddings into Neo4j, add that in as well. So I'll try to get that done here in a second. And then we might try to explore the chat memory. I don't know that we'll have a chance to get there. And then Spring Web for just REST API interactions. And then Ollama as my model of choice today. Again, you can pick any model provider you want to. I just happen to have Ollama already running today. So we're just going to stick with that.
Okay.
All right. Dump this into downloads. I'll pop it open here and open this in IntelliJ. Okay, so I'm trying to think. Yeah.
Downloading. It's probably the chat. Oh yeah, the chat memory stuff is new, right?
Yes, it is.
Okay, downloading. It's really fast. You're downloading. Your internet's pretty good, huh?
Yeah, it is. It is good. Not always flawless, but I'll take it.
Okay, here we go.
Yeah. Alrighty. I'm just quickly looking to see if we have any. Okay. I'll have to load some embeddings here in a little bit, maybe, if we get that far.
Those? Can you just use any embeddings or?
Yeah, so you have to plug in some sort of embedding model. So you have to pick a model. And then as long as there's an embedding particular model within that model family, it should be able to dump the embeddings in and store those. Typically, you store them on the entities themselves, and then you can just retrieve them with vector similarity search.
Yep.
So, alrighty. So everything looks good in the POM. Where am I here? There we go. This is what I was looking for. So application.properties, I'm going to, well, you know what? I'll just spin down my instance here in a little bit so I can go ahead and just do this. So we'll start with the just generic, we're going to need our username, just Neo4j. I think I need to check that actually. And then, because sometimes it changes depending on the database type you're using. So let's see, we need where's the URL? Repository. Nope, that's chat memory. Come on.
Well, at least that's working. That's nice. I'd love to see that.
Yep, it is there. Pick that up just fine. Yeah, so I know we're going to need a password as well. I'll come back to that in a second. And then the database sometimes is necessary. There's a URL there. URI. That's what I was looking for. We're not going to use Bolt. So I have that instance. So let me switch really quickly to that window up and running here. So this is the instance ID right there. And if I go back to instances, I can just look at, where is it?
You're going to delete this instance after the live stream,
I will. Sure. Yes, I will do that. Yeah, because otherwise this would be very bad practice. Don't do this at home. All right, and then
my friend and colleague Deshaun chimes in and says 4.03 exclamation 5 exclamation marks. You rock.
Yeah, using the latest and greatest because we want to break things, I guess.
What else is there?
Yeah, that is the thing with developer advocates. We always get the latest and greatest, which is awesome for showing the latest and greatest stuff. But on the other hand, sometimes you run into breaking issues. And it's like, drat, I'm trying to showcase this stuff and it's, not perfect yet.
My job title is developer advocate /tester.
Yes, exactly. Okay. So we go ahead and define a couple of things. Let's just stick with, we'll go with a class. We'll call it record, actually. Let's go with a record to keep things simple. Let's just say we have a movie and we'll have an ID that we need to add into that. I think it's a string movie ID, if I remember right. I can double check that. And then we have a title that'll get added to that. And then there's I think, description, if I remember correct as well. So that's out there. Let me just cross-check that.
I love that you're using records. I love that you've got, nice, clean, concise code bases.
Yeah, that it helps, especially when you're demoing stuff. So let's see here. Go back to my query. Grab some movies here and just pull this up and pop this back up. Okay, movie. Okay, we've got tagline. Sorry, released title and tagline. So there is no movie ID actually. It's interesting. Released. Okay, so that's right, because title is unique. So that's our ID property. So we've got title, tagline, released.
Title, tagline, released.
Yeah.
Title, tagline, and released.
Tagline and released. And I probably ought to double check that released property is a
date
string, because it might not be. It is let's see, released. It's an integer. Okay, good thing I checked. So we're going to go with integer released. Okay. So that
Nice.
should be good there. And then next we'll do the same thing, but we're going to do this for person. And maybe we will keep this simple. So first off, let's look at our person properties to double check what we got here. So just grab some persons here. There we go. Okay. Born name. So pretty easy. And born property is an integer. Okay, great.
Wow.
So we've got an ID and string name, and then we've got an integer born. Now, the thing that's the graphy bit is to actually connect these two things. So we're going to start from movie.
But so far, you've got a domain model and a data domain, and you've written 5 lines of interesting code.
Right. This is all boilerplate stuff, right?
But I mean, if it's 5 lines, does it even qualify? I mean,
is it code? I don't know.
Yeah.
So let's just stick with our actors for easy sake here. So let's see. Person acted in movie. So this is going to be a direction of incoming, because I'm coding all of this from the movie's perspective. And a person acted in a movie, which means that relationship is coming from person and is coming into movie. So it's incoming to the movie entity.
Yeah.
There's an acted in relationship, incoming to movie, and there could be multiple of these, right? Because you could have multiple actors in that appear in a movie. Let's see, did I do that correctly? I think I did. Yes. Okay. So let's see. We'll call this actors. So this just looks at the actors. Okay. Now let's plug this in with a repository. Let's just call this movie repository like that. And we're going to extend the Neo4j repository. Now, again, you could use a regular CRUD repository. That's totally fine. I like using the Neo4j repository because that lets me write Cypher, which is what I'm most comfortable with the graph database. And we have a entity type movie and the ID type of a string. And then we can leave this empty if we want to. Since it's a small data set, I'll go ahead and do that. And then let's just wire up a controller class here. So we've got let's call this movie controller. And this is a REST controller. And we're going to leave request mapping, right? Yeah. Let's just say /movies. And then we'll wire this up to be,
this is so cool.
Movie repository. We're going to call this repo. We'll need a constructor. Yeah, it's complaining at me here. Let's see. Just have it at constructor. Done. Okay. And then mapping. Let's just do a /all. Normally, I would not recommend you do a find all, because anything with a large data set, it'll try to suck up the entire graph and bring that back. But we're gonna go with it for today. Sure. So list, movie. And we're just going to call this find all. And we are going to do a return repo.
This is cool.
Find all. Okay. So now if I've set this up, it might complain at me for lack of like a vector store property or config, but we're going to find out. So
worst case, we just comment out the dependency, which we might have to do anyway. You've got 6 minutes.
That's true.
That's
yeah.
Okay.
So let's see. What did I call this? What did I name my project? Remember?
That part I do not remember.
Okay. Let's see. Chat memory demo. Chat memory demo. There we go.
Is your host name Elf Lord?
Yes, it is. It's an inside joke from a TV show that I love. So
it doesn't matter. That's perfect.
Okay. So this looks like it's up and running. Let's just see if we can query it. So we should be able to go to, I'm using HTTP. You can use curl as well. And then we named it /movies/all. And this should retrieve some movies from our data set. Oh, look at that. It came back. So right there, we've just plugged Spring Data into Neo4j and retrieved movies and actors for those movies.
And you set up that Aura instance right before we got on the show.
Yes. I think you dropped off for like 10 minutes or whatever it was. And I spun that up, dropped the query script in to load it. So yeah, this gives us a good start to things. Yeah. And so far, no errors. So that's great. That
was perfect. That was an actually perfect demo. I enjoyed learning about Spring from you. This was really, really amazing.
Well, if you got one more minute, I could show.
I've got 5, but I'm worried about you. If you feel like you can get it in under the gun.
Yeah, let's do a custom cipher, because I think that's way more fun and way more powerful, and something that I typically use most often. Because right now, the find all, find by ID are just derived methods that are provided out of the box by Spring, which is awesome. It's a great way to get started. However, like I said, it's not recommended that you do a find all, especially when you've got a really large data set, because it tries to pull everything back, which is really hard on the application and on the database and everything else. So what I usually do is do something like a custom query. So I'll do an @query annotation. And now I get to write Cypher code, which again, because I'm using a graph database, I'm very comfortable using Cypher. So let's say I might want to find movies, and I want to find the people who acted in those movies. So I've got an acted in relationship. So I'm just going to call this rel acted in. And all I did with that rel and the M up front is these are just variables to reference these entities in the database. So now you can name these anything you wanted to. We have person acted in movie. And let's say I want to just add in, let's see, return the movie, the relationship, and the person. And I can't type, obviously. So, and another thing that's kind of interesting about graph is you have these patterns, but patterns are unique based on the entire pattern themselves. So you have movie, person. Well, you might have movies and persons that are duplicated. For instance, let's say you have a person acted in a movie and they may have played multiple different characters. So they may have multiple relationships between, with that same movie potentially. Or if you just returned like a generic relationship, you would have multiple relationships, unique relationships. For Tom Hanks might have produced a movie, or he directed the movie and he also acted in the movie. So you would get unique patterns back. So what I've done here is I've just said, hey, I'm returning the movie, and then I'm going to collect the patterns, all of the patterns, and make a unique movie, basically row or object that comes back, collecting all of the connected entities as arrays, if you will, onto that movie, that unique movie. It sounds very confusing, but honestly, once you kind of see the patterns lined out and you see them duplicated like that, it's like, oh, I totally see why we're doing this now.
Yeah.
Okay, so we have multiple movies coming back, and there we go. And let's just say find all movies. And we're not going to pass anything in really, so that's fine. And then we can just wire up our controller. Instead of doing a find all, we can instead plug in our new find all movies like that. And then just start up the app again here, spin that back up, make sure it loads, and then I will ping the endpoint and just see it. You really should not see any difference.
Nope.
But now I am controlling the data that's coming back based on the query that I've defined.
That's so good. Oh, that's so good.
Yeah.
And with 30 seconds to spare, no less. That is so cool.
Yeah. And then hopefully the goal of this is just to kind of give a foundation start. And then once you get here, you can add in something like embeddings to for instance, the taglines of the movies. And then you can start doing searches like which movies are based in outer space or something like that. And it should do a semantic similarity search. And then you can retrieve all the actors and the directors and whatever else is connected to that.
We'll have to have you back. I'm going to relabel this YouTube video and just call it Spring Data Neo4j Step 1, and then we'll get into, wow, that was so good. Thank you. I know you've got a heart out. I'm sorry to have kept you this long.
That's all right. Thanks for having me. I loved it.
Thank you.
I would love to be back again.
Thank you. Yeah, soon, please. I'm here for the next few weeks. Let's make it work. All right. Bye.
Sounds good. Bye.